Hello everyone. Today again I'm here with taking my new session, and in this session I'm going to start with the same method with the same case, that is third one, right? Previously we did the third example of case 3, as we know. Hope you all practiced very well, and please make one lecture notes and note down these all the examples so that you can study easily, right? So starting with the next example. If you don't know how to solve, then please keep this all the examples with you and all the notes of case 3 with you so that you can go easily. Okay, so starting guys. Okay, here I have given the question. The question is solve in series, or else we can say that find the series solution for the equation xy double dash minus into the bracket 4 plus x into y dash plus 2y equals to 0. This example is very easy and it is same like case 2. Okay, so if you all did all the three examples, first, second and third, then you can do easily. So very first step, you have to check whether it is from ordinary or whether it is from singular points, right? So first check it out, and for that you may have to check, you have to find p of x, q of x. You have to check the denominators. In the denominators you have to put x equals to 0. If the denominator will be 0, then it will be from singular points. If denominator will be non-zero, then you will get ordinary points. Okay, and here I am getting singular points. After the singular points you have to find it is regular singular or irregular singular points. Okay, so till that all the procedure you have to apply. So do with your own self, and it is same like first example, like you have to write like first example. Okay, because here again I have written only main points, so please go like first example. Okay, so after finding the singular points you have to find its series solutions, and for the series solution, sorry, for the singular points we know that we having a solution y equals to summation k equals to 0 ck x is to m plus k, right? ये सिंगुलर पॉइंट्स के लिए ये वाला फॉर्मूला है, so that will be your singular points formula. Then after see the equation, there is given y dash and y double dash, so of course you have to first find y dash and y double dash. Now then after you have to put this all the values, you have to substitute this all the values in the equation number 1. Okay, so equation number 1 किसको देना है वो आपको पता है, that will be the equation which is given into your question, right? So putting these all the values in the first equation, so keeping x as it is, y double dash वहाँ पे रखो y double dash की formula minus 4 plus x keeping as it is. Okay, multiplication में y dash plus 2 as it is into the y. Okay, now next step, यानी कि in your first step you have to check whether it is given any brackets or not, and yes it is given. See the second term, here it's given a bracket, right? So first we have to open it. So first term as it is, see I've got this step, but you don't forget to write. Okay, initially if you don't know, then please don't forget to write, then please don't skip this step. Okay, so first term as it is, second term opening. So 4 into the y dash minus करके minus x into the y dash, and last term again as it is. Okay, now the next step you have to see, you have to check that you have to convert into the single term of x, right? So you have to convert now. So for this, see the equation. In the first term there are two terms of x, right? So convert into the single term of x, so that will be here x is to 1, and here it is given m plus k minus 2, so actually it will be x is to m plus k minus 1. right? Now next, 4 into this whole term, so it will be as it is, there is no x. Next term, x into this whole term, so here it will be two terms of x is to 1, and here this one, so actually it will be x is to m plus k on, that is this one. Okay, and last term again keeping as it is. Okay, now you have to check how many terms having a similar power. Okay, so for that, see the terms first and the second one that having a similar power, right? So, and that is m plus k minus 1. So just taking out the common, so from these two terms summation is common, then after c k is common, x is to m plus k minus 1 is common, m plus k is common, right? Itna common hai. Now next, which one is not common? That is m plus k minus 1, and here minus 4. So m plus k minus 1 minus 4, that will be m plus k minus 5, right? Hope you all got it. Now next term, this both term having again a similar power, so again you have to do the same procedure, right? So summation as it is, ck as it is, x is to m plus k as it is. Okay, now see these both the terms, here m plus k remaining term, and here plus 2, but see here minus negative sign is there, so m plus k, so here it will be minus 2. Okay, so into the bracket m plus k minus 2, rest of the terms as it is. Okay, so you will get this one term. Now for the next term, for the next step, the remaining term will be of the similar powers, right? So this both the terms you have to convert into the similar power. So for that you have to do the changes in the last term, and see your last term it is given m plus k, and you have to convert it is same, you have to make it is same like first term, and that having access to which one power, that m plus k minus 1 power, right? That is this one, see I'm circling it. Okay, so second term that having m plus k power, वहाँ पे आपको क्या बनाना है, m plus k minus 1. Okay, so you have to do the changes in the last term, mostly it will be in last steps you have to do the changes. Okay, so यहाँ पे भी आपको क्या बनाना है, m plus k minus 1, so keeping first term as it is. Okay, so यहाँ पे बनाने के लिए आपको क्या करना है, you have to apply one case, and that is for the k, right? So taking k equals to 1, so that we can make, right? So applying k equals to 1, so see I have written here k equals to 1 to infinite, in place of k I am writing k minus 1, right? So here m plus k minus 1 minus 2, so that will be m plus k minus 3, c k minus 1, और यहाँ पे आएगा x is to m plus k, in place of k we are writing k minus 1, तो यहाँ पे थोड़ा changes होगा, right? Okay, now see this both the terms having now similar power, but see the limits, see the series. In the first term it is starting from 0 to infinite, and in the second one it is starting from 1 to infinite. Okay, so of course the common series from this both the term is 1 to infinite. Okay, so from the first term you have to define one term, and that is for k equals to 0. So I'm just writing this term, so putting k equals to 0, so that will be this one 0, this one 0, right? So m minus 5 as it is, c 0, and x is to k 0, yani k m minus 1. See I have written the first term. Okay, now next one plus करके, now that will be the combination of these both the terms that having actual similar power. It means the series will be started from 1 to infinite. Okay, so here I have written 1 to infinite, m plus k, this m plus k minus 1 ck as it is, और यहाँ से आएगा m plus k minus 3 into the ck minus 1, and from both the series the common term is x raised to m plus k minus 1. Okay, so this will be your last simplification and this simplification is similar for all the cases. So again I am repeating, please note that this simplification is same for all the cases. Okay, so इक्का करोगे तो सबका आ जाएगा आपको. Now next one, you have to equate the terms, right? So here you are getting only two terms, so this both the terms equals to, you have to put 0, right? Because you are equating the terms of x. Okay, so the coefficients of x, that will be m into m minus 1 into the c0. See, I have written here this one. So this one equals to 0, but as we know all, c0 can't be 0. C0 possible nahi hai 0. Okay, so what you can find here, that m into m minus 1 equals to m minus 5 equals to 0, right? So that we can find a value of m, and that will be 0 and 5. Okay, and this is your first term equals to 0, yani ki the coefficients of x equals to 0. Now next we have to write another term, and that is given m plus k minus 5 into the sec k minus m plus k minus 3 into sec k minus 1 equals to 0. Okay, so that is I have written here into the next page. See this one, and from this term you have to make a coefficient subject of sec k, right? So sec k will be m plus k minus 3 into the sec k minus 1 upon m plus k into the m plus k minus 5, and you have to note its boundary also, and that will be from 1 to infinite, because see the value of ck minus 1. If you will put k equals to 0, then it will be c minus 1 here. Okay, so which is not possible, so that will be k minus 1 only, yani ki it will be from greater than or 1. Now next, okay, now see the roots m1 and m2, right? In the next step you have to find m1 and m2. Okay, m1 will be for the smallest root, and which is here, that is 5, because the roots we are getting 0 and 5, sorry, yes, 0 and 5, then it will be 0, not 5. Okay, so you have to apply for the smallest root only. So smallest root will be your m equals to 0. So before this you have to write m1 and m2. So m1 will be 0 and m2 will be 5. Then after you have to apply m1 minus m2. Now m1 is 0, m2 is 5. So 0 minus 5, that will be minus 5. And which is belongs to z. Here I have not written. It is same like the first example. I have written that this whole procedure very well. Okay. So please just observe that. And you have to write, it's compulsory to write. Here I have not written, but it's compulsory to write. Okay, so that is belongs to z. It means the third case will be applicable, right? Okay, now you have to find indeterminate form, yani ki any coefficients that having a indeterminate form. Okay, so वो आपको find करना है अभी. Okay, for this I'm first applying m equals to 0, so that will be ck equals to k minus 3, ck minus 1 into upon k into k minus 5, k is greater than or equals to 1. Okay, now applying one by one all the cases for k, like k equals to 1 2 3 etc. Okay, so putting k equals to 1, you are getting here c1 equals to c0 by 2. Okay, putting k equals to 2, that will be c0 by 12. Putting k equals to 3, you'll get c3 equals to 0. I have written all the values, you just check it out. c4, again it's being 0. c5, okay, c5 is being 0 by 0 form, because see here, k equals to 5, then it will be c4, and c4 what is given? 0, and upon 5 minus 5, 0. So in the fifth coefficient we are getting indeterminate form. Okay, so c5 will be your arbitrary constant, as we know all in every condition. Okay, in third case you will get any two coefficients, arbitrary coefficients. Okay, So C5 will be your arbitrary constants. So now find C6, that will be of course into the C5 form. C7 you will find that will be also, it will become into the C5 form because C5 we have told it's arbitrary constants. So आपको जो भी आंसर मिलेगा वो किस में आएगा, that is in the form of C0 and C5 because C5 क्या मिला हमें, indeterminate, और indeterminate यानी कि वो constant as it is रहेगा. Okay, like it is same like C0 को हमने ऐसे ही रखा है arbitrary constant, तो ये वाला भी वही रहेगा. Okay, so जो भी आंसर मिलेगा वो किस में आएगा, that will be in C0 and C5 only. Okay, so now at the last you have to write its series solution. Already हम लोगों ने आगे लिखा ही है, again repeating here, x raised to m summation k equals to 0 to infinite ck into x raised to k. Okay, so m equals to 0, so that will be x raised to 0, and here expanding the series, so that will be c0 plus c1x plus c2x square up to this on, right? Now putting this all the constants in the equations. तो यहाँ पे मैंने वैल्यू रखी है C1 की, then after C2, C3 0, C4 is being 0, C5 is being okay indeterminate, but C5 को हमने क्या बोला है, arbitrary constant. So C5 की जगह पे C5 ही रहेगा always. तो यहाँ पे C5 as it is. Okay, C6 का आंसर हमने कन्वर्ट किया है C5 के फॉर्म में, राइट? सो इट विल बी C5 अपॉन 2 into x to 6 up to the so on. So यहाँ पे आपको जो सीरीज जो दो कॉन्स्टेंट्स मिल रहे हैं, राइट, वो किस में मिलेंगे, एक C0 और दूसरा मिलेगा आपको C5 में. So just taking out the common C0 and C5 and make this series. Okay, okay guys, hope you all understood this example. So total we did 4 examples of case 3. One more or two examples is still remaining, so in the next session we will start with our next example, fifth one. Okay, thank you.